Okay, so we're calculating lengths of sides using trig, so a continuation of the last lesson. Just going to move this a little bit. Okay, so all of the ratios here are listed. You don't have to memorize them. They all will be on a formula sheet, and they're also in the back of your workbook, on the back page, but it is a good idea if you can remember them. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So we're going to use those to answer some questions. So here it says the length of the hypotenuse of the triangle is 15.7. Determine the lengths of the other two sides. So label them with some variables. And so this angle, I want to also label the sides with reference to that. So the hypotenuse is this, and then this side x is adjacent. It's touching the 29, and this is opposite. So if I want to find x, I'm going to go cos of 29 degrees equals x over 15.7. So then x is 15.7 cos of 29. Get your calculator out, make sure it's in degree mode, and go 15.7 cos of 29, and that's 13.7 meters. Then for y, compared to 29, that's opposite, and I always use a side that's given to us rather than a rounded 13.7. So opposite over hypotenuse is sine. So sine of 29 is y over 15.7. So y equals 15.7 sine of 29. Where's my calculator? So 15.7 sine of 29. And that's 7.6. Okay, take a look. Both of these sides that we calculated, each of them should be less than the hypotenuse, and they are, okay? And kind of looks somewhat reasonable. I mean, really, this side should be longer. This measure here is 29, should be a little bit less, but it's at least in the right ballpark, as we say. So example 2, determine the lengths of sides x and y. Well, notice these are lowercase x and y. So where are those? Well, lowercase x is always opposite angle capital X. So that's going to be lowercase x, and then lowercase y is here, not switched around. Okay, so that's kind of a convention that if capital letters are used for the angles, then the sides are lowercase across from it. So in this case, this is your hypotenuse, this is opposite, and this is adjacent. Okay, so let's do find x. Well, x is opposite over hypotenuse, so sine of 65 is x over 20. So x equals 20 sine of 65. So 20 sine of 65 is 18.1 centimeters. And then adjacent is y, so that's going to be cosine. Cosine of 65 is adjacent over hypotenuse. So y equals 20 cos of 65. And that's 8.5 when we round it. Okay. Then example 3, given that the angle A in the right triangle shown is 58 degrees. Okay, so this we can label as 58. And the length of the adjacent side to A is 5.2. So there's two sides that form angle A. This is going to be our 90 degrees. Okay, I should have had that labeled actually, but it says it's a right triangle. So the side opposite that is the hypotenuse. So the side adjacent is 5.2 inches. Determine the lengths of the other two sides to the nearest tenth. So we want to find this side and this side. Okay, so comparatively, if I use red here, this is opposite, this is adjacent, and this is hypotenuse. Okay. All right, so let's find opposite first. Well, what side do we know? We know adjacent. So I'm going to use tan. Tan of 58 is x over 5.2. So x equals 5.2 tan of 58. So 5.2 tan of 58 is 8.3 inches. Okay, now their hypotenuse, I always like to use one of our sides. So this side is adjacent and this is hypotenuse. So that would be cosine. But now my unknown is in the denominator. So remember, when the unknown is in the denominator, you divide. So 5.2 divided by the trig ratio. If it's unknowns in the numerator, you multiply by the trig ratio. If it's in the denominator, you divide by the trig ratio. So that's going to be 5.2 divided by cosine of 58. And that's 9.8. Now, should be longer. Y is the hypotenuse, so make sure it's longer than either of the other two sides, which it is. Okay, next on the next page. So some things to know, some definitions. Angle of depression, that's the angle formed from a horizontal downwards. So I think of, okay, when you're feeling kind of depressed, you're feeling down. So you look horizontally and then downwards. That's angle of depression to your sight line. Angle of elevation would be if you're looking up. Say they were looking up to the sun here. Okay, this would be angle of elevation. Elevation. Okay. So it says Angelina is in the hot air balloon, spots a bag of money on the ground below. She radios to Brad, who is standing directly below the balloon. Okay, so forms a 90-degree triangle to run there. If the angle of depression for a line of sight is 38 degrees, so this is 38 degrees, and her height above the ground is 215 meters, determine how far he has to run. So that x. So the thing is, this 38 isn't in our triangle, but we reviewed already a few days ago that if you have two parallel lines, which the horizontal is, right, horizontal lines are parallel, then this 38 is the same as this angle. It's the Z rule. So now we have a triangle. We know this angle is 38. This opposite side is 215. This is adjacent. So we're going to use tan. So tan of 38 is 215 over x. So our unknown's in the denominator, so you want to divide. Okay, so 215 divided by tan of 38 is 275.2 meters. Now what you could do, if this is 38, I'm going to switch to red. You know that that's a 90-degree triangle here. So 90 minus 38, it gives you what, 52? Okay, so then you could go, okay, well, then I'm doing tan of 52 equals x over 215. So x is 215 tan of 52. And if we look at that, 215 tan of 52, we get the same value, 275.2 meters. Okay, so two ways of doing that one. Next one, Sarah Thana is flying a kite in Glenmore Park. At one point, she has let out the entire 156 feet of string. That's your string. The angle of elevation for our line of sight to the kite is 54. So you want to compare then from the horizontal. So there's a horizontal line, or pretty close, and that's going to be 54 degrees. Determine the horizontal distance from Sarah Thana to the kite. So basically, not that you'd always do this, but we want to know what this distance is here. Okay, from directly underneath the kite. So this is adjacent, and this is hypotenuse. So we're going to use cosine. So cosine of 54 equals x over 156. Okay, so 156 cosine of 54 is 91.7, and that is feet. Okay, then determine the height of the kite above the ground to the nearest tenth. If Sarah Thana is holding the kite string at eye level and her eyes are 5 feet. So this is 5 feet. That triangle, same one that we just did. Okay, so we know this is, we've already calculated this part. This is 156. And so we want to know the entire height, right? So this is 5. Now we want to know this part here. And this angle of elevation was 54 degrees. So we want to use opposite over hypotenuse, which is sine. Okay, so 156 sine of 54 is 126.2, and that is feet. And then height above the ground, height of kite is going to be 126.2 plus 5, so 131.2 feet. Okay, and that's it. Let's check here. Yep, that's it.